Good morning. Am I audible?
Yes, sir.
Yes, sir.
Yeah. So this is table 1, where we'll be having all these minterms 2, 6, 8, 9, 10, 11, sorry, 15. So what is the corresponding binary number for 2? Can anyone of you tell?
0010.
0, 0, 1, 0. Good. Okay. For 6, 0, 1, 1, 0. For 8, it is 1, 0, 0, 0. For 9, it is 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, and 15 is 1, 1, 1, 1. So this is the first table where we are taking the equivalent binary number for the given expression, and these are the minterms and these are the corresponding binary numbers. So for now we will prepare table 2. So the first column is group, second column is minterm, the third column is binary equivalent. So what is the first step we have to do? The first step, we have to write the equivalent binary. And what is table 2? What we have to do? We have to, yes, we have to group the number of ones in the occurrence. So there is no zero number of ones. So for group 1, we will be grouping 8 and 2, as they have only one number in 2, that is 2, 8, 0, 0, 1, 0, and 8 is 1, 0, 0, 0. So this is group 1. Next we will take group 2. In group 2, we have to identify the number with 2 ones, that is 6, 9 and 10. So I will take 6, 9 and 10. 6 is 0, 1, 1, 0. 9 is 1, 0, 0, 1. 10 is 1, 0, 0. Sorry. 1, 0. So this is the second group. This is the second group. So next group is we need to identify the numbers with 3 ones. So the number with 3 ones are 11 and 14. 11 and 14. So binary equivalent for 11 is 1, 0, 1, 1. For 14 is 1, 1, 1, 0. And the last group, which contains 4 ones, that is 15, 1, 1, 1 and 1. So this is a table 2. Did you get it? Yes.
Yes, sir.
Yes, sir.
So this is table 3. What we have to do here? Can anyone tell me? This is again group, minterm. This is A. Yes. Can anyone tell me? What we have to do now? याद है या नहीं है?
Sir, no, sir. We have to group.
We have to group what?
Making dual.
So the
Yeah. We have to group the numbers which have one difference. Okay. So we have to compare 2 with all the numbers in second group, that is 6, 9 and 10. So first we will compare 2 with 6. So is the in place D it is 0, 0, C it is 1, 1, in B it is 0, 1 and in A it is 0, 0. So in bit position B there is one difference, so we can group 2, 6. Okay, and wherever there is one difference, so we have to consider only one difference. If there are more than one difference, so we cannot group them. So the number is 0 dash 1 0. Is it good? Now we will compare 2 with 9. So at D it is 0, it's 1. At C it is 1 and it is 0, so we cannot group there, right? So we'll compare 2 with 10. So there is one change in bit position A, so we can group 2 comma 10, that is dash 0 1 0. Now we will compare 8 with 6, so we cannot group 8 and 6. We'll compare 8 and 9. So there is one different in bit position D, so we'll group 8 comma 9. Okay, so the difference is in bit position D dash. Now we will compare 8 with 10, so there is bit change in bit position C, so we can group 8 sorry 8 comma 10. So it would be 1 0 dash 0. So this is group 1, where we have grouped group 1 and group 2, and we have formed the dual group. So now we have to compare group 2 with group 3. So I will compare 6 with 11. So there are more than one differences, so we cannot group 6 and 11. I'll compare 6 and 14. So there is one change in bit position A, so I will group that with 6 comma 14. So it is dash 1 1 0. Now 9 is compared with 11, so there is one change in bit position B, so we can group 9 and 11. So it is 1 0 dash 1, and 9 is compared with 14, so which cannot be grouped. 10 is compared with 11. Of course there is one change in bit position D, so we can write it as 1 0 1 0 1 dash. So now I'll compare 10 with 14. So there is one change in bit position B, B. So I'll group it with 10 comma 14. That is 1 dash 1 0. Okay, so this grouping is done. So second grouping is done. So I'll take the third grouping. Okay, I'll compare 11 and 15. So there is one difference at bit position D. So I will 11 compare group 11 and 15. So the change is at bit position B, so it will become 1 dash 1 1. So if I compare 14 and 15, so there is bit position change in D, so I will write it as 14 comma 15 14 comma 15. So bit position is at 1 0 1 1 dash. So is it clear? Is it clear how we derived table 3?
Yes, sir.
Yeah. So shall I erase table 1 and table 2? Now we will prepare table 4. What is the first column? What is first column? First column is group. Second column is min term, and the third column is binary equivalent A, B, C, and D. So now what we have to do, we have to compare the tables 2 6 with this. So we can compare that 2 6 and the 9 11 can be grouped. There is, sorry, they cannot be grouped. 2 6 can be grouped with 10 14. So there is bit position change at A. So I will write, kindly drop down your attendance in the uh, chat box. So session may abruptly, we have only 9 minutes. So I'll try to finish off this example. If it is not possible, I'll finish off this in next this. Okay. So with first group, I will group 2 6 2 6 10 14. Yes, Sonali, any problem?
No,
You have
it's
raised the
clear.
hands. Raise your hand. So the position is dash dash 1 0. Next 2 6 cannot be grouped with any other number over here. So I will compare now 2 10 with other. So it can be grouped with 6 14. So it is 2 10 and 6 14. So the number is dash dash 1 0. Next I can compare 8 9 with 10 11. So 8 9 10, 11. So the grouping would be 1, 0, dash, dash. Next, we can group 8, 10 with 9, 11. So it would be 8, 10, 9, 11. The grouping is 1, 0, dash, dash. So each term is been covered. So this is the first group. I will take the next group, that is I will compare group 2 and group 3. So group 3, 6, 14 cannot be grouped with any of the numbers in group 3. We can compare 10, 14, 11, 15, 10, 14, 11, 15. So the comparison would be 1 dash 1 dash. Second grouping is 10, 11, 14, 15, 10, 11 and 14, 15, 14, 15. So it is again 1 dash 1 dash. So further, if we compare this table T4, so we cannot uh, simplify further, as we cannot group group 1 with group 2. So if I consider this 2, so it is one prime implicant. If these two, it is the another prime implicant, and this is the another prime implicant. So I can write this as C D bar A B bar, and this is A C. Okay, so we'll try. We have left out with 4 minutes, so we'll try to draw the essential prime implicant table. What is the expression? Can any one of you tell me how many digits we have? We have 2, 6, 8, 9, 10, 11, 14, 15, right? So this is 2, 6, 8, 9, 10, 11, 14, and 15. For group 1, which is C, D bar, this is A, B bar, and this is A, C. So in CD we have 2, 6, 10, 14. So I will mark 2, 6, 10, and 14. And for AB it is 8, 9, 10, 11, 8, 9, 10, and 11. For AC it is 10, 14, 10, 11, 14, 15. So 10, 11, 14, and 15. So if we consider the column wise, so there is one left out. We can only group vertically. So all three are, so this is covered over here, 10. So this is also covered. We can group it. We can group this. But there are the terms which are not grouped vertically with other main terms. So all three are the essential prime implicants. So the answer is, the essential prime implicants is C D bar plus A B bar plus AC. So this is the solution for the expression. Okay, I hope it is very much clear to you guys. So if you have any doubts, you can ping me on my WhatsApp, and we'll discuss over there. So we have the session can be ended at any time, so please post your attendance on the chat and leave the group. Thank you.